All right. Yeah, so this is Dev Talks with Near, and I'm joined by Dorian Crutcher, and I'm Ben Couric, and we're part of the developer relations team at Near. And so I was just going to run through a little bit about Near, a little bit about the beauty of working with Near. I was going to run through a smart contract, an NFT smart contract, creating a Near wallet on testnet, and then deploying the contract and having an NFT show up in the wallet. That was the sort of agenda, and then talking about a little bit more in depth about Near. And so, yeah, a little bit about who I am. So my name's Ben. I'm actually an intern for Near. I joined about 2 months ago. Um, and I've been super heavily involved in the NFT space over the last year. I started a company back in February focused on NFTs. And I just came back from Paris in an NFT conference back in Burgundy. Yeah, so I'm part of the developer relations team, and Dorian can talk a little bit more about what that entails.
Yeah. So the developer relations team, like our entire goal is to one, support developers and like building on Near. And we do that by creating example applications, creating tutorials, help managing our documentation, also just like talking with the blockchain community in general, just to like let them know about like what's going on in Near and let them know what like, Near is essentially too. So with that, again, if you guys just check a plugin. But like if anybody ever has any questions about Near general or any developer questions they may run into, feel free to reach out to Ben GI or anyone else on the DevRel team through our Discord, Telegram channel.
Yeah. So then I was just talking about how I was super involved in NFTs, and this talk is going to be primarily focused on NFTs because they are a booming part of crypto right now. And then a little bit about what my company does is we're an NFT platform for social good. So we're focused on bridging the gap between charities and cryptocurrencies. So we're focused entirely on bringing charities into the crypto space and having NFTs and perpetual royalties all for charities. Yeah, so then a little bit about Near itself.
Oh yeah. So one thing that's like kind of like unique to Near itself is our account system with our function call access keys and our full access keys. So before getting to the account system itself, I'm going to talk about these two different types of access keys that we have on Near. So with this thing called a function call access key, essentially is a permission, it gives them certain permissions or restricted permissions to decentralized applications, meaning that you have a way for users to log in easily in and out of applications. It's a great way to like onboard users to like the Near like ecosystem if they don't already have a Near account. And also allows for like specific contract calls being made to and from well, I guess made on behalf of like the account essentially. It also has this like great budgeting system, meaning that like no single like transaction can go over something like 0.25 Near in a transaction. So it protects users from like quickly racking up like transaction fees if a account contract seems like malicious or poorly made in a sense. We also have this other access key called full access keys. These ones should be like much more protected. So like with full access keys, like this, I mean, you're essentially giving a decentralized application like full access to your account, meaning they can like send all your Near tokens. They can create these things called sub accounts, which I'll go into in a minute. They can deploy contracts to your account or any of these sub accounts that it creates. For example, like the Near wallet, if you go to wallet.testnet or sorry, wallet.near.org, that's something that uses a full access key, but that's something that's like managed by us in a sense. But like with that, you can like do all these actions there as like a one example of like what has a full access key. With full access keys, you can actually like make multiple full access keys as well. So like say like, like this is, good and bad depending on like how you view it or how you want to use that. But let's just say someone manages to get one of your full access keys, you can make another one and then revoke and like delete that one as well, making it like useless. So that specific full access key will no longer have access to your account. Hopefully that'll make sense. Ben,
Yeah. Well, so yeah, I mean, yeah, that's pretty much the bulk. Another interesting thing is that each of these access keys have their own nonces, and so on Ethereum, you've got nonces right on an account level. So you've got your hexadecimal, account ID kind of thing, and that has its own nonces. And so this is one of the reasons why Near is quicker, is because every key has its own nonce. And so you can scale really easily with multiple access keys, and you can give different applications different access based off of your needs. And so another really cool thing, just to knock it out of the park, is that you can actually give a specific contract specific restrictions on methods, right? So if you had a contract, you could create an access key that only allows the user to call a specific method on that contract. And so you can chain these function call access keys in really cool ways to do really cool things. Yeah, and so you cannot transfer any near with a function call access key. You can only do that with a full access key. So if you lose your function call access key, somehow you're not screwed, right? So function call access keys are a great way to do really cool things and to log into dApps. But full access keys, you want to keep them safe, and you don't want you don't want to lose them, because you could actually even delete your own account with a full access key. But yeah, do you guys have any questions before we move on?
So is this coupled to like the same account? Like is a full access key like a private key,
Yeah.
or this
Yes.
is a bit different?
Yeah, so they're key pairs basically. It's like a public-private key pair, and so you can take that key pair and you can perform an action on behalf of a user. So if you had a function call access key for an NFT contract, right? So let's say you have you log into a dApp, right? And what you're doing essentially is you're creating a function call access key on behalf of that account. That way you can call specific methods on behalf of that account, right? So it's basically just a key that allows you to do specific things on behalf of the account, right? But those actions are limited with the function call access key, right? So you can't do everything with a function call access key. So if you have that key pair, you can only do specific things, and out of those specific things, you can't transfer any near, right? So it's a restrictive way to allow people to do things on smart contracts. Full access keys, same thing. If you have the full access key, you can act on behalf of the user, but the things that you can do are much less limited. You can do anything with a full access key. So you don't want to lose that full access key. Does that make sense?
Yeah,
Cool.
that makes sense. Thanks.
All right. Moving on.
Yeah, so I mentioned the name account systems a little bit earlier. So if any of you worked with Ethereum, you're probably like familiar with like the private key hash that you have, which is like a long, essentially like string of like letters or numbers, kind of like 0x1 2 3 4 go on and so forth. I think like that's kind of like, it's cool if you're like in the blockchain space already, but when it comes to like, it's like people who are new to blockchain or like just the everyday person, like running a decentralized application, like they probably want something a little more recognizable, a little bit easier to understand. So Near has these things called the human readable named account system. So you can create something as easy like Dorian.near or Door.near. Like that could be like my identifier for my account. And that could be the thing that I give to other people to then identify my account. What's also kind of cool about like these like named account systems that you can create these things called sub accounts. So for example, like say I have my master account called door.near, like that's my company name or something, like and my company has like a bunch of like little sub shops that I run, or it's like a mall or something. So it could be like door.near can make NFT shop.door.near. So I create that account, it's my sub account, I funded it, but it's still kind of like a completely like separate account. And if that makes sense. So like essentially like it's just a way I can like use to like organize my account structure. So I just want to be clear at like that NFT shop is like should be active NFT.door.near is a separate account from like door.near. But for example, like say for our entire like examples repo on like Near repo, each of our different examples have different sub accounts to then deploy different contracts to. So we have like a fungible token .examples.near or like NFT .examples.near, each holding one single contract that's deployed onto it. So sorry, stuck a lot there, but hopefully that all makes sense.
Does anyone have any questions about that? Cool. Yeah, it's nice to have human readable account names for sure, and it's powerful, and it allows for a lot of like the sub accounts allow for a lot of organizational structure, which is nice. But But yeah, so that was a little bit about Near and like some of the cool things. Also, in case you're wondering, Near is, or in case you didn't know, Near is proof of stake, and we are sharded. So we're proof of stake sharded blockchain, and we've basically learned from those stakes of Ethereum, and we're basically ETH 2.0 if they were actually out, but with human readable account names and with all these cool access key structures. But yeah, so that's a little bit about Near. And so I have this super simple NFT contract that I put together. It is super basic. It's written in Rust. And what I was going to do is I was going to go through actually creating a Near wallet on testnet and then deploying the contract and minting an NFT and having it show up in my wallet. Also, if you can hear my bird, I apologize. He is super loud. But yeah, so let's first go to wallet.testnet.near.org and we'll create an account. And so this is where you can put your human readable account name. I have no idea what I want to do. Maybe we just call it Benji Demo. Benji Demo, that works. Awesome, cool. So we'll reserve that account ID. And so here's where you can secure your account. There's different ways where you can sort of secure your account. Here, the easiest is to do a passphrase. And so that's just the 12 words that you use. So you have your 12 words, you copy them, you put them somewhere, and I'll put them in the URL for now. And then it's going to ask you, hey, what's word number 2? Oh, and it is early. So type that in, verify and complete. And so what that's done is I've now created an account on testnet, and testnet is all for it's like basically mainnet, but everything is test tokens and there's no real money. And so you get initialized with 200 Near, and so I've got roughly $2,000 to play with. And so now what I'm going to do is I'm going to go over to my terminal and I'm going to use this nifty tool called the Near CLI. And so basically what that is this different ways to interact with the blockchain using a CLI. So you can do things like delete an account, you can query for the keys for a given account, you can deploy a contract, you can call methods on a contract, you can view the state of a contract, you can send money. It's basically just a way to interact with the blockchain. It's a super simple API or SDK. And so now what I'm going to do is I'm going to log in. And so what that's going to do is it's going to basically create a full access key on my machine that I can use to go ahead and deploy a contract and send money and stuff like that. Because if I tried to do that right now, like send from the account Benji demo.testnet to the account, this is my real testnet account, and I tried to send like 5 Near, it would be like, oh, I don't have a key for that account, right? So we need to actually log in and put that key on our local machine. So to do that, you just call Near login, and that's going to redirect you to the testnet Near wallet, and it's going to say, hey, an application is requesting full access, right? And so that's my local computer, and I want to create a full access key on my computer and see how it's like, this, be careful, it can create new accounts, transfer tokens, deploy smart contracts, delete access keys, all that stuff, right? And so I'm going to say, yeah, I'm going to type in Benji demo.testnet because that's what I'm trying to log in with. It's going to confirm, and then it's going to say, oh, nice, we've logged in. And so now if I try to do that command again, send to this account, it's going to go through, sending 5 Near, and just wait for it to go through. Boom. So now it's done. And there's another really neat tool with Near called the Explorer. And this is where you can go and you can visualize and see all of the transactions and methods that are being called on any account. So if I go to Benji demo.testnet, you'll see here that we have a transaction where I transferred 5 Near to benjamin.testnet, right? So first you created the account, I added a full access key. This full access key is for the wallet site. So when you created the account, it created a full access key for the wallet. And then here's where I created the full access key on my machine. And then here's where I transferred the Near, right? So now we've got my account on my local machine and everything's good. We can start looking at the contract code. Are there any questions up until that point, or am I good to go through the contract? All right.
Yeah, I think you're good to go. Also, most people here probably have never even looked at Rust. So like, as you're explaining it, you could kind of like briefly touch on some like Rust conventions. I think that'd be helpful.
Sure. Yeah. Awesome. No problem. So this is basically just a super simple smart contract, and the smart contract is a struct. So Rust is if you're familiar with C++, then you won't have that big of problems with Rust. Rust is very similar to C++, but yeah. So basically what's happening is first I need to initialize my struct. And so this is basically just all the information of my smart contract. It holds my variables, all of the fields, the attributes, all the collections that I want in my smart contract, right? And it's a public struct called contract. And then all of this Borscht serialize, Borscht deserialize, all that garbage. This is basically just so that you can serialize it and put it on chain, and then you can deserialize it when you view the state. It's not really important. Near bindgen is basically just how we connect with the Near network, and it's sort of like, basically it's just you need it if you want to put anything on chain. That's not really that important. But yeah, so I'm going to start in my struct by having this public owner field. And so this is basically just the contract owner. It is of type account ID, which is basically just a wrapper around a string. So I'm saying I've got an owner ID in my struct that is a string, right? And then I've also, for NFTs, if you look at the standard and stuff, you need some way to track your token IDs for a given account. And so that's where I initialize this collection called tokens per owner. And that is of type. So if I have basically the way that it goes is you can say let or public, foo, and then you put a colon and you specify the type, right? So if I had this is basically saying I've got something called foo and it is of type string, right? So here I've got public variable called tokens per owner, or public field called tokens per owner, and it is of type lookup map, right? Now what it's looking up is it's basically just mapping an account ID to a set of tokens, right? So account ID again is a string, it's a wrap around a string, and then a token ID also is a wrap around the string, right? So the public tokens per owner means that it's a public field. It is of type lookup map, and it is mapping an account ID to a set of tokens, right? So this is keeps track of all the token IDs for a given account. And then we've got tokens by ID, which is basically the same thing, but it maps a token ID to this custom token struct. And so this token struct, I'll go through a little bit later, but it basically just holds information about the token. So rather than having a token ID string, you can map the actual string to a struct, which holds more information. And then we've got token metadata by ID, which is basically just an unordered map. So again, it's mapping a token ID to its metadata. And so if you look at the standard, we've got standards for all this stuff at this cool nifty thing called the nomicon. And so if I look at the non-fungible token standard, I've got a standard for metadata, and that basically shows all the metadata that you need. And here you can see that type token metadata, which holds the title, the description, the media, the hash, number of copies, all that stuff. So this is basically just the metadata for the token. So I'm mapping a token ID to its metadata. This extra storage in bytes per token, you don't have to worry about it. It's not really that important. And then I've got the public metadata, which is the metadata for the contract. So going back to the standard, we've got the metadata for each token, but then the contract itself also has metadata. So this would be the NFT contract metadata, which holds the spec. So this is what version of the standard you're on. It has the name of your contract. It has the symbol. It has the icon, base URI. Basically, it's just the metadata for your contract as per the standard, right? And then in Rust, this is a little bit complicated, storage keys, but just the long story short is whenever you initialize a collection, you need to prefix it, which basically avoids data collisions when you reinitialize a contract or when you redeploy a contract. So this is all just fancy Rust stuff for avoiding data collisions in your collections. But yeah, so that's basically the core sort of it is basically just the struct and all of the core information that we keep, right? So this is literally just the information that we're storing. And then we've got the implementation. And so this is where we're implementing the public methods in our contract. And so we've got this cool macro here called init. And so what that does is it's initializing a default state, and you can't initialize a contract more than once unless you delete the account and redeploy, right? So this is basically saying, let's initialize some of these fields and some of these variables with some starter information, right? And so I've created this initializer here called new default meta, which basically is calling self new, right? Which is calling this initializer here with some predefined default information. Otherwise, I could also call new, but then I'd have to pass in my custom metadata, and that just takes a lot of time. Now, what basically diving in a little bit deep is you public means that you can call it from the CLI. Basically, anyone can call this method. FN obviously means function, and then you've got the name, you've got the parameter, so owner ID, which is of type valid account ID. And what this means is it's basically just the same thing as the account ID. It's basically a wrap around a string, but it has some extra properties that checks to make sure that that account ID is valid. So it checks to make sure that there's no weird characters or anything like that. Yeah, so this basically just a security thing. And then what this means is that this is the return type. So this is going to return self, and self is basically just the contract struct, right? So you got this public function, new default meta that takes an owner ID and it's going to return self. And what it does is it returns self. And so in Rust, you can return something without a semicolon. It's confusing. I had a hard time wrapping my head around it at first, but it's literally just, if you don't have a semicolon, that's what you return. And so here I'm calling self : new, which means I'm calling the function new, which is a part of self. And because I don't have a semicolon, I'm returning this whole thing, right? So I'm returning the return type of new, right? And so I'm passing in owner and I'm passing in this NFT metadata, which I've predefined here, right? And so it's calling this new function over here, which is another initializer. So it's basically like you can either call this new default metadata or you can call this new function here. It's up to you. I just added this so that I don't have to keep typing in metadata in my CLI, right? And so what it does is it calls new, and then let is basically just like, in any other programming language, like, it's initializing a new variable. So I'm initializing a new variable called this, and this is of type self, right? And it's returning the tokens per owner, tokens by ID, tokens metadata by ID, owner ID. It's basically just initializing all of the variables. And so here's where I have the prefix, which is the storage key, and this is all fancy Rust stuff to avoid data collisions, but all you need to know is that it's initializing the collections with a prefix. And then here, owner ID, I'm taking the owner ID here, valid account ID, and what .into does is it converts from one type to another. And because owner ID in my struct is of type account ID, and I passed in something which is of type valid account ID, this is a Rust thing to perform that conversion and convert the valid account ID into an account ID, right? So I'm passing in the owner, I pass in some metadata, and then I initialize the data collections. And then this, because there's no semicolon, I'm returning this, right? So that was a lot. Are there any questions about that aspect of the smart contract? No? Okay, cool. Let's keep going. I hope it's not too confusing. Once you wrap your head around it, it does get a little bit better. But yeah, so I've got this new default meta and I've got this function called new, right? So we've also got this measure min token storage cost, and what that's basically doing is this might be a good time to explain the storage model on Near, but let's do it anyway. YOLO. If I go to my actually, I think I've got it here, wallet.testnet.near.org, you've got a wallet balance, which is basically every account has got something called like a storage reserve. And so what that means is our storage model is the more you store, the more Near you have to have locked up in your account, right? And so if I deploy a contract and keep adding state, so I'm storing a bunch of information on chain, I'm going to have to reserve a storage cost for that. And so anytime you store anything on chain, you need to pay storage for it. But the cool thing is it's just reserved, it's locked. So if you release that storage, so let's say you burn a token, right? So you've minted a token on chain, you need to pay for storage. But if you release that state and you no longer use it, that storage that you've released then becomes available for you to spend again. So it's basically just, I need to hold an amount of storage in my account in order to deal with the storage that I'm using up on my account. It's not that complicated. It's just, yeah. And it's not super expensive either. But yeah, so I've got some, like basically on my contract, I need to be able to maintain some balance for storage. And so in the contract, I've got this measure min token storage cost, and basically all this is doing, it's not super important. I'll go through it really quickly just because it's interesting, is it's measuring how much storage it would cost to put a NFT on chain, right? So let's say it's 0.01 Near to put an NFT on chain, then now I know anytime I put something on chain, I need to charge the user 0.01 Near so that my contract has that 0.01 Near to cover storage. So that's basically like, let's insert something and then let's remove it and we'll measure the storage. That's literally it. It's like a helper. It doesn't really matter. It's just so that we never run out of storage. But yeah, so we've got these initializers, and then we've got this function here. It's not public, which means not everyone can call it, but yeah, so that's that. And now we've got our metadata, which is exactly what you saw in that Nomicon. You've got basically all that information, right? So you've got basically everything from the standard, and then I've got that struct token, right? So eventually we're going to expand this when if you start introducing more aspects of the standard. Ooh, we got a question. Q.
Yeah, don't worry about it. It's Quintus, Q, whatever you want. Basically, so I just want to ask about the memory. So is it the same as Ethereum where you're paying a once-off cost to write to persistent storage, or is there a difference that I missed?
Yeah, so you're not actually, so the difference is that you're not actually paying. So it's not like I'm going to pay and I'm never going to get those funds back. It's just you're reserving them in your account, right? So if you put something on chain, you need to you need to basically, you need to maintain that near amount in your wallet, and it's locked up.
I understand. Oh, so you basically have an incentive to remove things that you don't use anymore, so it doesn't clog up the system.
Exactly.
Oh, okay. Okay, that's interesting. Thank you.
Yeah, no problem. But yeah, so I've got this token struct here. Right now, it only has the account ID, so the owner ID of that token. But eventually, like in the standard, right now this contract is only for minting. But eventually, there's other standards, and this token struct will get bigger and bigger and bigger. And then we've got what's called this JSON token, and this is what you're going to get back in any of your view calls, right? So maybe I'll touch on the difference between a view call and like a view function and a change function. But basically, it's just anyone can go and query information from the chain without being logged in. So for example, I could go in my CLI and I could do near view the contract that I want. Maybe I'll just use testnet, and then I'll call NFT tokens with a limit of I don't know, 5, for example. And so this is going to just query information from the chain. And this is my own personal contract. But what I'm saying is I don't need to be logged in. So view calls is anyone can just go and view information from on chain. Also, the hand is still raised. Do you have a follow-up question, or did you just forget to lower it?
Sorry, poor etiquette.
No problem. But yeah, so the view call is you don't have to be logged in. You don't have to be signed in to do anything. You can just query information from on-chain. And that is different from a change method, which is you basically have to sign a transaction and you have to be signed in order to change any aspect or sign a transaction, right? And so these here, whoa, sorry, my VS Code is being weird. So this, for example, this is a view call, and it's just returning the metadata. And so the difference in Rust between a view call and a function call is for view calls, you have to pass in self, but for function calls, like if I go to mint, you pass in mutable self. And mutable in Rust is basically just meaning that the variable is going to change, right? So I'm changing self in this mint because I'm going in and I'm inserting a token into my collections. Whereas the view functions, like if I go back to the metadata, you're only passing in self because you're not changing anything. And so this function NFT metadata can be called by anyone, and it is just a view function, right? And yeah, so that's just a really quick a difference between view calls and function and change methods. But yeah, so we've got this token struct, and then we've also got the struct JSON token, and this is what's being returned in the view calls when we want to query information from the chain. So here we're going to return the token ID, we're going to return the owner ID, and then we're going to return the metadata. So super simple. On chain, we're storing the token, right? So we're mapping, like if we go back to the lib.rs, we're mapping a token ID to a token, but we don't want to continuously have to store all of this information for like all of this like all these JSON tokens because they have more. Everything is about optimizing storage. But yeah, so this is what we're going to return back in our view methods. But yeah, so that is super simple about like some of the collections, right? So we've got the JSON token, we got the token, we got the metadata, and then we've introduced our first view call or view function. So let's actually deploy this and see this view function in action. So we've logged in with Benji demo.testnet, and the first thing we're going to do is we're going to run this script called yarn build, and what that's going to do is it's going to compile these contracts into WebAssembly. Also, ignore all these warnings. This contract has stripped everything other than just the minting. So if I go to like the approval, all this is like fill this in. So I'm getting a bunch of warnings because I haven't actually done it in this branch. But yeah, so what it did is it wrote main.wasm. So it built the contract and it outputted this wasm file, and that's what's going to be stored on chain, right? And so now what I can do is I can do near deploy. I'm going to specify the path to my wasm, so out/main.wasm, and I'm going to specify the account ID that I want it to be deployed to. So in this case, it was Benji demo.testnet, right? So it's starting the deployment, and then it should take about 1 second, and it's done deploying to Benji demo.testnet. So if I go back to the Explorer and I refresh, we can see that this contract has been deployed. Now, I cannot access any of the methods until it's been initialized. So if I try to call that view method we were looking at beforehand, just to show what it was again one more time, it was this NFT underscore metadata, which just returns the metadata. This .get is just basically getting the value, and then unwrap in Rust is, I don't know if I want to get into this, but unwrap basically, there's no null types in Rust. And so because metadata is an option, like if I go back here, what a lazy option means is it basically just means that it can be something or it can be nothing. And so unwrap is basically forcing it to be a value. If there's no value there present, then the whole contract will throw. But yeah, so if we didn't specify a metadata, so in here, because we set the metadata here, that won't throw. But if that option, for example, we didn't have, like we took this out and we tried to call this self.metadata.get.unwrap, because technically speaking in the contract, by writing in that it's an option, we've specified that the contract either can have it or it may not have it. By saying that if we try to unwrap a none value, then it'll throw. But yeah, so this function is just getting that metadata. And because we haven't initialized our contract that we've just deployed it won't work as far as I know. NFT, I'm going to call, actually for this, I'm just going to export an environment variable here so that I don't have to keep writing Benji demo.testnet. So I'm going to call near view on the account NFT, and I'm going to call NFT metadata, right? And so, yeah, it's basically saying, it's not initialized here. The contract is not initialized, so we can't call that method. So now let's actually go ahead and let's initialize it. So we'll call the new default meta because I don't want to pass in any specific metadata. So we'll call near call. I'm going to call that NFT contract from the account ID of the same account. So I'm calling Benji demo.testnet from the account Benji demo.testnet. And I'm going to call the method new default meta. And then some of the arguments that I'm going to take, and let's make this a little bit bigger. So I need to pass in an owner ID, right? So if I look back at the code, all I need is an owner ID. So I'm passing in an owner ID, and we'll make that owner Benji demo.testnet. And let us go. So here, scheduling a call, Benji demo.testnet, new default meta. And again, if I go to the Explorer and I refresh, boom, it's called that method new default meta. And if I go to the actual transaction, you can see that I passed an owner. And now if I try that metadata again, then you can see that it returned the spec, the name, the symbol, and these are all none basically in Rust. But yeah, so we just deployed the contract, we initialized it, and we called our first view function, which was that let's get the metadata. All right. Now let's step into really quickly the mint function, and we'll call mint. So this mint function takes in a token ID, it takes in the metadata, and then it takes the receiver. The receiver is basically just who we want that NFT to go to. So let's step into the code real quick. So we're going to initialize this initial storage usage. And so this env is basically just, it stores a bunch of information. Here, let's read it. Blockchain specific methods available to the smart contract, right? So this can return information like the signer, it can return the predecessor, it can return here the storage usage, it can give you the attached deposit, right? So this is basically just information about the transaction that's about to happen, right? And information about the contract and stuff. So we're going to get this initial storage usage. This is useful so that we can make sure that the user is actually attaching enough storage that will, is it basically that the user is attaching enough storage to cover the cost of minting this token. So we're going to get the owner ID. So again, this mutable means that we're going to set this variable owner ID, and by making it mutable, it means it can change. And because receiver ID is an option, this is fancy Rust stuff for basically saying if we have some receiver ID, so if we've specified a receiver ID, then we're going to set owner ID equal to that receiver ID. Now, again, remember that into is that conversion. So it converts from a valid account ID into an account ID, right? So this is basically, again, just super, this is Rust magic for let's set the owner ID if we've specified a receiver ID. And then let's get the token struct, right? So the token will create a new struct of type token, and we'll put the owner ID in it, right? So if you remember that the token struct only had the owner. So yeah, so basically what we've done to this point is we've set the owner of the token if we've specified a receiver. If we didn't specify a receiver, it's just going to be the person who called the method. But yeah, so then we've got this token, and then we're going to assert whether or not it already exists, because you don't want to be minting something with the same token ID. And so this self.tokensID.insert, this insert actually returns whether or not, like it returns basically whether or not that insert was successful or not, right? So I'm gonna insert, right? And then if it's none, that means we're fine. But if it's not, then the token already exists, right? So this is inserting the token ID into the struct and make sure that the token doesn't exist. So this is how we keep track of the tokens, right? And then we're passing into that the token ID and we're at the token. So remember, it's a map between a token ID and a token. And then what we're going to do is we're going to insert the token ID and the metadata, right? So we're passing in the metadata, right? So we're passing in metadata, and you remember that this is a map between a token ID and the metadata. And then this is an internal method that we've created that just adds the token to the owner. So do you remember that token to owner struct, or token to owner collection basically mapped a token, an owner ID to a set of tokens. And so this is just super yeah, it's just, I mean, I can go into this, but yeah. So this public crate, I actually didn't know what this meant until a while ago. But the Coles notes is it means that it's not anyone can call it, but you can call it from within the contract itself. But people from using CLI can't just call this. But yeah, so we get a token set, and if it doesn't have any tokens, we create a new collection, and then we insert the token. And then we insert that basically that mapping back into that collection, right? So we're gonna insert that token to the owner, and then what we're gonna do is we're gonna see how much storage that's cost us, right? So we get, now that we've inserted that token, let's see how much storage we're using, right? So this is the net storage. So we called the storage usage here. Now we're gonna recall and get that minus our initial, and then from there, we're going to refund the deposit. So we're going to refund. So let's say someone called this and attached like 100 Near, for example. We don't want to just take all 100 Near. We want to refund them everything that it didn't cost for the storage, right? Because we don't want to be like a main contract, basically. But yeah, so that's that. Are there any questions about that? Because it is a lot, especially the people who haven't seen Rust before. Ooh, there is a chat here. I didn't see that. Oh, but it's just Dorian. But yeah, so if I'll wait like 5 seconds, and if there's no questions, I'll move on to actually minting. Okay, great. So let's move on to the actual minting part. So we've deployed the contract, we've initialized it. Now let's mint our first token. So you remember, it takes in our token ID, it takes in some metadata, and it takes in a receiver. I don't want to write it from scratch, so I've actually got this call all ready to go here. Let me copy and paste this here. And so basically, let's make this a little bit, oh, I can't do that, oopsie. Make it a little bit bigger. Sorry. But I'm calling I'm calling on the contract underscore demo.testnet. I'm calling the method NFT mint. I'm passing in a token ID of 0. In this case, the receiver, let's just make it Benji demo.testnet. And then I got to pass in some metadata. So the metadata is I need a title, a description, a media, and that's basically all I'm gonna do, and copies. Because if you remember in the metadata, these are all optional, so you don't actually have to pass in any of this, technically speaking. But because I want it to show up in the wallet, I'm gonna pass in a title and I'm gonna pass in a media. I don't actually have to pass a number of copies, but why not? And then I pass in a deposit. So let's say I passed in like, I don't want to do 100 near, let's do 10 near, for example. And I went through and I ran this command. Oh, this is not, oopsie, there shouldn't be a 0 here. It sent it to a completely false account. Let's do this and let's change the token ID, otherwise it's gonna throw. Yeah, so now if I go to the Explorer and I go back to that account, we see here that we've called NFT mint and we've passed in the token, the receiver, some metadata, and copies. And I attached 10 near here. So if you go through and you look at the execution plan, this is the contract refunding me all the storage that I didn't use, right? So just to make sure that I don't waste all my near. But now if I go to the wallet, wallet.testnet.near.org, and I go to my collectibles, I've got this cool NFT that I've just minted. And it shows up in the wallet and it shows it under our contract. But yeah, and then, yeah, so that's basically the core of the smart contract. Are there any questions up until that point? Or can I pass it on to Dorian to quickly talk about some resources, and then we've got a grant thing that we want to talk about, and then that's it. Are there any questions up until this point? The presentation is almost finished. How does the payment work for minting the NFT again? So how do I get out of this? Whoa. So basically, because the contract is using up some storage, like if I go back to the account, you see that now I'm reserving 2.7 near for storage. Before it was small, but because I'm deploying that contract on chain, it does cost some near. And so basically on the contract level, because you can do basically anything you want on the contract level, I'm making it so that users have to pay my storage for deploying, for minting an NFT. And so basically what's happening is that the user's attaching some near, right? And then the contract calculates how much is being used up for storage by minting that NFT, because I have to add that state to the contract, right? So the contract does, it checks how much storage is being used, and then it refunds the rest. But in terms of actually payment for the NFT, in this specific case, I'm making the user attach some near. Like if I go back and I try to call this with like a really small amount of near, the contract will panic because it'll say, hey, you didn't attach enough storage for basically to do this. It's going to go through, and here it's saying smart contract panicked, you must attach at least this much Yocto near to cover storage, right? So because in this specific case, me as the user, I didn't attach enough near to cover that storage, the contract panicked. But yeah, so it's basically just I'm transferring the contract some near in order to cover that storage cost, right? And so if I were to, adding near as a deposit is different from using up gas. Gas is automatically taken from the signer, so that's on top of the deposit value. So if I deposit near, right? So like in this transaction that I had way back over here, this transfer 5 near to Benji, I attached 5 near, but I also used up some gas. But from a Benji man's perspective, he still got 5 near, right? So this gas is taken from the signer's account. And so the signer has to pay for the gas. The gas is just the computational power. So you have storage and then you have gas, right? So the storage is whatever you're storing on chain, but gas is paid basically just so that you can do that computation, right? So anytime you do any computation, gas is being used, right, on the consensus layer. Does that make sense? So it is different, right? So one's computation and then one's actual storage on chain. Awesome. Yeah, so any last questions before we move
Yeah,
on
I have a
to...
question. So
Yeah,
does
go ahead.
the pricing of the storage, is that fixed or does that change as more storage is used?
I'm not actually sure. Let's check storage. I'm pretty sure that it's fixed. I think it's like 1 byte for, or like some amount of near for 1 byte. But Dorian, do you know? I don't actually know off the top of my head. I don't. I think it's fixed, but don't quote me on that.
I think it fixed. I think I think it actually does change as like the blockchain is like managed over time, but like I believe it is a fixed value. Yeah, right there. Yeah, 1.9.
Yeah, 100 kilobytes per near token, basically.
Mhm.
So that's not actually that
okay.
expensive. Yeah.
So
And
in order for that to change, would you guys have to fork the client code, or is there some mechanism for changing that?
I have no idea. That's more like protocol level people decision that I'm not sure about.
Is there a big divide in the workforce between smart contract development and protocol development?
Well, smart contract development is mostly for dApps. On the protocol
Yeah.
level, that's where like all the tools, like if I go back here, for example, like, there's like, using near SDK, like, and using, near bindgen, like the actual the usages. So there's like the protocol level, and then there's the sort of like SDKs and stuff. The protocol level is like how like the chain works and like all that like near core
No,
stuff.
I understand the distinction, but I'm asking in terms of the people working on it, is it quite siloed? Or do similar people work on, there's some people who work on both? I guess that's my question.
I don't know. So I think the chain people and the protocol levels just like they sort of just do their own thing, but like there's a lot of communication, but I don't know if there's anyone that does both. Maybe there's like one or two, but I don't think that it's like the sort of general, like in general you work on everything kind of thing. If that makes sense. If that answers your question.
Okay, yeah, thank you.
No problem. Any other questions? If not, I'll pass it on to you, Dorian. Talk
okay.
about some resources.
Yeah, so of course, like you can find you can find like Benji, me, the rest of the DevRel team, and just like the Near community as a whole on our Discord channel as well as our Telegram channel. So if you prefer, say, Telegram, you go to Near Dev. It's our developer developer Telegram channel. So yeah, at Near Dev. And you can also find our Discord like invite link just by typing in near.chat into like into your search bar, and that should pop up for you. If you go back to the resources page, of course, you can find a bunch of like good technical information as well as some tutorials on our docs page. And if you actually want a good on-ramping, experience into kind of like the Near ecosystem, you can go to our Near University. It's a collection of all of our educational resources, from tutorials to a high level to a deeper dive into Near itself. And every day at 11 a.m. Pacific Standard Time, we have live office hours. So that's where all the DevRel members, all the DevRel team, as well as some of the Near like core team, comes in live to talk with our community members and answer the questions, or sometimes just to like hang out and just like talk about like random topics in like Near or just in general. But it's primarily there just to like connect with you guys and to answer any questions you may have. If you go to the next slide. Oh yeah. Okay. So we want to talk about want to do a quick overview of our like Near grants program. So we have a variety of grants that we offer our community. We have open source grants that range from like 1K to 30K. We have startup grants, which comes in chunks of 3K to 5K to 10K. And any startup can reapply for grants if you're hitting your agreed upon milestones. We also have grants for like educational initiatives that range from 1K to 10K. And we also have a list of bounties, which can like be achieved in like various amounts or or valued at various amounts. Gonna go and so all grants are essentially issued in USD or euros or near tokens. So you can go to near.org/grants to find out more information about our grants page. And the essential approval process that goes along with that.
Yeah, like I've got a grant. It's super simple. We actually just launched this thing called Fast Grants, where we can give up to $20,000 to anyone, and they'll get it basically in the next 24 hours. If they're doing like a cool project or something like that, it's really interesting. And it's basically just we have basically money build out on our platform, and we want cool projects to come up and stuff like that. So yeah, it's a really cool initiative. It was just launched, like we just launched this $800 million ecosystem fund, which is really, really cool. So yeah, if any of you have any cool projects or anything like that, hit us up in Discord, and we'll see what we can do. But yeah, I mean, that was really the bulk of the presentation. It ended up going to basically exactly an hour. But yeah, Dorian, if you have to go, feel free to go, because I know you had some other stuff to do. But thank you so much, guys. If you have any other questions, just.
Oh, you're muted.
Who's muted?
Oh, you're muted, Ben, for a second. I don't know if you're still talking.
Oh, no, that's done. And now you guys can ask any
Okay.
questions you want or anything like that.
So I have a question related to the protocol again. So I guess I'm sorry if it's not something you can answer. But so I guess like the question with like a lot of new layer ones will be, what's the roadmap for getting it? Yeah, I'd assume now at the moment it's not really decentralized. What's the plan for getting it to the point where you have enough people staking near for it to be, actually financially costly to take it down?
Yeah, I mean, I know it's in the works to significantly lower the validator seat price by a lot. That comes with also our introduction of sharding more and more, like releasing more shards. But I don't know specifically about like the sort of roadmaps that are in place for that. I know that they're really trying to reduce the seat price for validating, so that we don't have to run as many nodes, and that it's more decentralization comes into par. Is that like, that's all I really know? Does that sort of answer your question?
Yeah, I think that's a general answer. Thank you.
Yeah, sorry about that. But yeah, any other questions?
I mean, just quickly, do you have any advice for actually like learning Rust? Because I mean, at least to me, it seems quite different in terms of like how you actually program compared to other languages, and specifically kind of applied to blockchain. I guess
Yeah.
yeah, it's like one complicated thing after another.
Yeah, so we've got like, if I go to, like, we're actually in the middle of revamping some of our like, we've got Rust tutorials, like quick start guides, and like going through exactly what's like happening in Rust. Yeah, how I learned Rust, which I don't recommend, is I just looked at code for a really long time and tried to figure out what the heck was going on. I don't really recommend that, but I mean, there's a bunch of like like LinkedIn learning courses and like a bunch of YouTube videos and stuff like that. I don't know, like I don't know. I have a love-hate relationship with Rust. I definitely didn't do it the correct way. But also just looking at smart contracts, I find, and like just going and getting your hands dirty is always a great way to start. I mean, you can start with something super simple. Like, we've got a lot of like really, really, really simple but sort of boring smart contracts. Like, for this tutorial, I went like sort of a little bit beyond, like in terms of doing an NFT contract, which is not always the easiest. But like, we've got a bunch of like Rust smart contracts that are super simple that you can just take and maybe just expand upon a little bit. Yeah, I mean, that like, doing maybe a course or two, and then getting your hands dirty with actual smart contracts. So we've got a ton of them. I think that would probably be the best way to go.
Yeah, that makes a lot of sense. Thanks.
Also, I guess like a design decision. Why Rust instead of something like Solidity or another language?
Yeah, we have assembly script and Rust. Rust is a mature language. I mean, it's fast, it's memory efficient, and like memory leaks is like not a thing because it's super super secure. It's fast. The my personal favorite is like it yells at you if you don't do something right, and it basically won't let you compile. And like basically, if your code compiles, you're pretty much guaranteed that it'll work because if you Whoa, I muted myself. Sorry. If you try to like, if you miscode anything or like, like it's so secure. But yeah, it's fast. It's secure. I don't know. I don't know why exactly they chose it. I mean, I can only speculate. But yeah, we are
Yeah, I
introducing
think that
more
was
languages.
yeah, I think that was a helpful answer. Thank you.
Cool.
All right. Yeah, no, there's any other questions, and they could probably end here. Thanks so much, Ben. This was, yeah, I think it was a great intro. Also, yeah, definitely helpful for people. I've been trying to get more people to kind of like learn Rust because it's been important. And we're seeing like across ecosystems. So yeah.
Awesome. Yeah, thanks so much, guys. Really appreciate you guys listening into the presentation. If I could grab a copy, that'd be great.
Yeah.
I think it was awesome meeting you guys and doing this for you. But yeah, thanks so much. You know where to find me. I'm on Discord. So if you have any other questions or want to do anything, just let me know. But
Sure.
other than that, thanks, guys. Have a great evening.
Sounds good. Have a good one.
Bye.
Thanks.